For this video, we will be writing the equation for an ellipse. The chart I'll be using is on page 620. So here's the information given. The center of the ellipse is at 0, 0. The vertices are located at 0, positive or negative 5, and the value for C is 3. So looking here, since the vertices are at 0, positive or negative 5, if you sketch a little graph of this and plot those, you'll see they're located, so the center is at 0, 0. So they're located on the y-axis, so up 5 and down 5. So there are your vertices. With that information given, you can look at the chart on page 620, and you'll see then that we were dealing with a vertical ellipse. So we are dealing with a vertical ellipse. So the standard equation for a vertical ellipse is x squared over b squared plus y squared over a squared equals 1. So a squared is always your larger denominator, and it is associated with the y-axis, which is a vertical axis. So with this information given, then we know what the value for a is. So the value for a equals 5, because that's always the distance from the center to your vertices. So this is your plus or minus a. We know the value for c, which is 3. Now we need the value for b. So we will use this relationship. We will use b squared equals a squared minus c squared. So b squared is what we're solving for. So this is a, so a squared is 25 minus c squared, which is going to be 9. So when you do the math there, you're going to get b squared equals 16. So that's what we need. So the value for b squared is 16, a squared is going to be 25. So we can write the equation. So the equation will be just x squared, because the center is at 0, 0, so x squared over b squared, which is 16, plus y squared over a squared, which is 25, and that would be set equal to 1. If we wanted a quick sketch of the rest of the graph, since b squared is 16, b is 4, so from here we would go to the right 4 for another endpoint, and to the left 4 for the other endpoint, and you would have an outline of your graph. So doing one more. Little technical difficulties there. Let's do one more. So let's say you're given this information. You're given that the foci are at plus or minus 4, 0, and the y-intercept, or the y-intercepts are located at positive or negative 3. Okay, so if we sketch a quick graph of it, we can see that the focus points are located at positive 4, 0, and negative 4, 0, and those are located on your x-axis, which is the horizontal axis. So we are dealing with a horizontal ellipse. So again, the chart is on page 620. So we have a horizontal ellipse, and I know that based on where these are located. So here, this is in your chart as plus or minus c, 0, and since they're on the x-axis, it's a horizontal ellipse. So the y-intercepts are at positive negative 3. Those are just the endpoints, because they are not located on this main axis where the foci are. So those, that is your value for b. So we do not know a yet. We know our value for b is going to be 3, because it's the distance from the center to those endpoints, which happen to be the y-intercepts here. And we know the value for c. So c is equivalent to 4. Okay? So we are going to write the equation. So for a horizontal ellipse, it's in this form of x squared over a squared plus y squared over b squared is equal to 1. So we're going to solve for a squared. So I'm going to use the relationship b squared equals a squared minus c squared. Since b is 3, so b squared would be 9. So I have 9, a squared is what we're solving for, minus, since c is 4, c squared will be 16. Okay, so add 16 to each side. So we have 25 equals a squared, so there's our a squared. So we're going to be able to substitute into this equation. So the equation for this ellipse is going to be, so the answer is going to be x squared over a squared, which we solved and got 25, plus y squared over b squared, which we knew because we knew what b was, is equal to 1. The ordered pairs for the vertices would be at